Let us learn about a typical embedded system using the block diagram. Typical embedded system. Here we go. So here I have a typical embedded system, and let me explain this block diagram to you. Okay. So a typical embedded system is divided into two parts: the real world and the embedded system. So the reason they have separated the real world and embedded system is to show that the embedded system works on the basis of the real world. It takes the input from the real world and gives the output according to the user's need or specifics. So a basic embedded system contains this pattern of components, this pattern of so the specific or so the typical embedded system contains this processes and activities going on in it. Okay, so the first basic thing is the system core. This is the CPU of the whole system. Consider embedded system as a computer. It has a CPU in it. This does all the operations like the ALU, arithmetic logical units, plus, minus, or, and, etc. Also load and store operations from the memory. This one processes it. It can be FPGA, application specific IC, digital signal processor, system on chips, any microcontroller or any microprocessor. Then we have memory. Memory is to store the code or the algorithm of the specific task that embedded system should perform. We basically store something called embedded firmware. Here we can see we have embedded firmware. So what is embedded firmware? Embedded firmware is basically the software or the code stored in the memory. And how will we store the code in the memory? Using the communication interface. Communication interface is basically the commuting criteria for using the output, the input system of the embedded system, and giving it code using a communication interface. If I simplify it, we have code here. To upload it into an embedded system, we need a communication interface. Okay, this is it, communication interface. So communication interface can be USB, UART, DB9, any communication interface. Basically, using this communication interface, we upload the software firmware into the memory. We upload the code, we upload the algorithm that this embedded system needs to perform, and in turn the system core gives the output via output ports or on the screen of the personal computer or laptop, etc. The reason it is two ways because it is a two-way communication. We upload the code, the system gives the output. Same in the memory. The memory gives the data to the core, and the core stores this data or the algorithm in the memory. Then we have input ports. Input port and output ports both are one-sided. If you look at the input ports basically take the input from the real world and feed it into the system core. The input ports can be connected to the sensors or any input devices such as switches. It can be keyboard, it can be mouse. These are all the input devices. There are many, but these are some examples for input devices. And we have output ports which are connected to the output devices. Devices are also known as actuators. Examples include buzzer, LEDs, printers, monitors, etc. These are output actuators. With all these It also contains some other supporting ICs and subsystems. If you take, for example, any general microcontroller or embedded system such as Arduino, ESP32, STM32, they contain some supporting ICs such as DACs, ADCs, system ALUs, etc. So this is the basic typical block diagram for the embedded system. It's very much simple, easy to explain, and hope you like the video. Thank you.